This is the third and final video in this module where we are building the Simio model of the serial manufacturing line. You can see we have a turning 5 stations in series: turning, drilling, milling, inspection, and pack, where the result of inspection is a three-way decision between rework back to the mill, good parts which are packed and shipped, and bad parts which are rejected. We have all of the parameter information here, and then the assignment, we have a number of model components to incorporate and performance metrics to do. And so in the first two videos we built the base model and then added some of the required components, and so you can see the model running here. In particular, what we have is the tally statistic for counting the number of time good parts are milled, and the plot here for tracking the average WIP and the instantaneous WIP. We'd already set up the experiment initially, and so on the current video, this last video, what we will focus on are these the experimental responses. So we have 6 experimental responses: the average number of entities in the system, average time that entities spend in the system, average time that rejected parts spend in the system, and so on. So let's look at implementing these experiment responses in our model. The first response we'll do is the average number of entities in the system, and we can use the exact same expression that we use for our plot. Notice when we did our status plot, we used the expression parts.population.number and system.average. We'll use that exact same expression, so I'm going to just copy it to the clipboard here because I'm going to use it here in just a second, and then I'll go to my experiment, create a response, and I'm going to name my response average NIS, and then I will simply paste the expression that we had in our for our status plot as the expression for the experiment response. If I could get my mouse to work here, there we go. So now we have the parts.population.number and system.average. The second user statistic is the average time in system that entities spend in the system. And notice that the third one, well, let's go look. We have 2 average time in systems, one for all entities, and the second one just for rejected parts. So what we'll do when we create these is we will use 2 different mechanisms for time in system. For the overall time in system over the population of parts, we'll simply use parts.population like we did for the status plot, except we'll use time in system rather than number in system. To get the rejected parts, we'll use the feature of the sink that lets us get the time in system of entities that went through this sink. Everything that goes through this sink are the rejected parts, and those are the ones we want for our third response. So for first one, let's just do average NIS. TIS, sorry. Well, if I could type, here we go, average time in system, and then we'll just use the expression builder, and we want parts, population, time in system, average. And since the assignment specified that we give the time in minutes, we'll just change the time units here to minutes. And then for our second one, this is the reject TIS. As I said, we'll just use the sink tally that's done automatically. So we want bad, time in system, average. Average time in system for entities that went through this particular sink. And as before, we have specified that we use time units of minutes. So we'll put those in. So now that we have our first 3 done, let's run the model and just make sure everything looks like we expect it to. Remember, if you have an expression wrong, then it won't show up. Well, I have to reset. Then nothing will show up when you run it. And so assuming we have them right, let's let it run one replication and see. Okay, so we have our values anyway, so let's just stop it. We won't check them now. We'll go ahead and do the other 3 before we check the values. So let me reset it. So we've done the first three, A, B, and C, and we will now look at doing the last three. The utilization of the pack machine, the average number of times each good part is milled, which was computed in our user-defined statistic above, and finally the hourly rate at which good parts are finished. So we go back to our model, and the utilization, very straightforward. We want, let's just call it pack util, and the expression is the pack dot capacity dot scheduled utilization. Pack dot capacity dot scheduled utilization, so that gives us the utilization for that server instance. Next we have the average number of times each good part is milled, and recall that we created a tally statistic for that, so we'll just use that tally statistic value here. And so we'll go back to our model, definitions. Our tally was called good parts milled, and so we can get that response. Let's call this average good parts milled, for lack of a better name. And then we'll just call our tally good parts milled average. And there we go. So we have average good parts milled. So this final statistic, or this final experiment response we have to do, we have to actually compute something. So in the previous 5, we were just using things that were pre-computed by Simio automatically based on the type of the type of objects we were using. And for this last one, the hourly rate that good parts are finished, we have to compute that ourselves. So let's look back at our model and see how we might do that. Basically what we're going to do is we're going to, if I can find our model, let it run for a little while, is we want to count entities that go through the good sink. These are the good parts, and we want to take that count and divide it by the runtime. So if we have a total number of parts that went through good, and then we divide that by the runtime in hours, that will give us the hourly rate at which entities depart the system. So let's go back to our experiment and let's create our new response. Oops. Create our new, why did I create 2? Let's remove that guy, click too fast. Go back to response 7 and let's name this throughput, THPUT, and we need good input buffer number entered. So that's the total number. So if I just leave that here, leave that as our expression, then when we run our replication, what this is going to give me is the total count of entities that went through the buffer over the simulation time. So let's let this run for a second. Hopefully it won't take too long. It's pending. There we go. And so this gives me the total number that were created or that went through the system over our replication time. Now note that since we have a warm-up period, we have to subtract that off when we compute the throughput time. So I'm going to go back, reset my experiment, go back to throughput, and now I need to divide this by the total time. Once again, the total time is going to be time now, which is the ending time of the replication, minus run warm-up period. So run warm-up period will subtract off the warm-up period, and so what we end up with is the total number of parts that entered the input buffer to good over the 500 hours that we're actually tabulating results, and then dividing that by the ending runtime minus that warm-up period. And so we now have that result. If we go back and look at our model and think about what we hope to find while the model runs, what I hope to see is that I have 20 parts per hour arriving. That's my arrival rate. I have some dropping out here, so I have an expectation of somewhere around 18 or 19 parts per hour leaving. Recall we have this 5% probability, but since we have this feedback loop here, the rework loop, this is going to end up being slightly over 5% that get rejected. So we go back to our experiment. Hopefully we've had a couple of runs now, and now we see this, that we have 18.7, as I said, somewhere over 18, not quite 19. Oops, I left this one response here. We don't need that. And so that completes our model. Remember to do the experiment responses. We had already created the tally statistics, so we used that. We used a whole bunch of built-in properties for the average number in system, the reject time in system, pack utilization. We use built-in functions, and then we computed the throughput ourselves by simply counting the number of entities that went through the good sync and then dividing that by the simulation time. So that completes this module, and you should definitely give this model a try. Build this on your own, build the static model to do the verification, and so on.